Welcome to Nabeel Math Academy. This is Dr. Mohammed Nabeel. In this video, we are going to discuss about the factorization by different techniques, the GCF and the Trinomial Factorization Theorem and a special factor. First of all, we go to the greatest common factor that we call it as GCF. Greatest common factor is GCF. So here you have to take the highest power, the greatest common factor. What is the common factor in these two terms? So this is the first example we have. So x square plus 4x, I will take x outside, you will get here x plus 4. So this is the GCF. Now the next one here, we will have what is the common factor? What is the difference between the last problem and this problem? Here you will have only one x, but here the variable x, y and z. For this term, I have to just concentrate the first number. So 12, 16, 20. What is the greatest common factor? So 2 is a greatest common factor as well. But we have to take the highest common factor, greatest common factor, which is 4. So I will take 4 outside because it is 4 times of 3. This is what 4 times of 4 and this is 4 times of 5. So therefore 4 is a common factor here. Now the next term, choose the smallest power of x. What is the smallest power of x? Which is x power 2. X power 2. So I write it here. X power 2 is a common factor. And what about the y? Take the smallest power of y, which is y power 2. So I will take the y power 2. And the next one is z power 1. So because you have z power 1, z power 2, z power 4, therefore z is a common factor. If I take it outside, what is the remaining term here? So you will have remaining 3, only the 3 term, because everything we have taken outside here, plus, so here 16, 4 outside, the remaining is 4. The next term, x power 3, x square outside, 1x is remaining. And y power 4, y square is taken outside, y square is remaining. Here is z. The next one here, 4 outside, remaining 5. And then x power 2, because x power 2 outside, remaining x power 2, because it is x power 4. Out of x power 5, x square outside, it is y power 3 is common. Now z power 4, z is common, so z power 3 is a common factor. So this is the GCF of this term. Now the next one here, so what are the common factor here? Therefore this is a common factor. So I will take this part here. So you will get x minus 4 is outside. Remaining term you will have x 2x plus 1, this part, and plus 3x plus 5. Now if you simplify this one, x minus 4, now x with the x term, so you will get 5x, and the number with the number you will get here 6. So this is the final answer. So if you study these 3 type of problem, the whole GCF problem is over. So only you will have the 3 kinds of problem in the greatest common factor. Now coming to the next one, the factor trinomial. What do you mean by trinomial? You will have 3 terms. So this is a very important technique we will follow in all the mathematics. Now here, how will you factor this form? So what are the leading coefficient? 1 here. Now multiply. What are the multiplication? So you will get 6. So what are the possible multiplier? 1 into 6, 2 into 3, and 3 into 2. So same thing. Now whenever you will have this minus, both minus. So whenever you will have this minus, so this is plus, both plus, both plus. So both the number will be plus. So which one is correct here? So this is actually the same. 2 into 3 and 3 into 1 is same. Yeah. Which one is correct here? In this case, the 5, I need the 5 here. So if you add these two part, you will get 7. So here I will take this part and I can write it directly because the leading coefficient is 1. I write it directly x plus 2 and x plus 3. X plus 3. Now coming to the next problem here, we have here it is minus. Whenever you will have a minus here, we say both negative. Both the term is negative, the minus. So let us go with this one. The leading coefficient is 1. Multiply. So you will have 6 possible multiplier, 1 into 2, 1 into 6, 2 into 3. So here both minus, I say both minus. So if you add, you will get minus 7, which is not there. So if you add this part, it is minus 5, which is there. So I can write it directly because the leading coefficient is 1. So therefore, it is x minus 2, x minus 3. If you want to check, you can check. If you multiply these two part, you have to get the plus 6. So it is plus 6. When you add these two part, you will get minus 5. It's the same story here. If you multiply, you will get plus 6. If you add, you will get plus 5. Now the next one we have here, the leading coefficient is 1 and multiply with 36. So it is minus 36 you will have. Now write it all possible multiplier of 36. 1 into 36, 2 into 18, 3 into 12, 4 into 9. So going on. Now whenever you will have this part minus, we say this is large number minus. We say here. So whenever the middle term and the constant term minus, large number is minus. The bigger number is minus. So according to that one, the bigger number of these two is 36, bigger number of these two is 18, bigger number of these two is 12, and here 9. So I want to get minus 5. Which one is correct in this case? So the last one. So if I added these two part, you will get minus 5. Now I write it directly because the leading coefficient is 1. So x plus 4, x minus 9. You can write it x minus 9 first, x plus 4 next. No issue. It's the same since it is in the product. Now the next one here, multiply the same thing. One leading coefficient multiply with this one minus 18. So here 1 into 18, 2 into 9, 3 into 6. So this is a possible multipliers. So whenever the constant term minus, we say small number is minus. Small number is negative. So if you put it the small number, out of these two, the small number is this. Out of these two, the small number is 2. Out of these two, this small number is minus 3. So which one is correct for this type of problem? So I need the plus 7. Therefore, you will get the plus 7 by adding minus 2 and plus 9. So I can write it directly. The value will be x minus 2, x plus 9. That's it. Now coming to the next one. Here, what are the difference between these problems? So here the leading coefficient is not equal 1. So I have to go with the grouping here. So how will you do this one? So it's the same story therefore. So if you multiply, you will get minus 24. So 1 into 24, 2 into 12, and then 3 into 8 and 4 into 6. Since it is both minus, therefore the large number is minus. Large number is minus. So which one is correct for this type? Yeah. Maybe here the question is plus, I think. Yeah, question is plus. Now, so if it is minus, therefore the both number is will be minus. So what happened here? Minus, 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 then minus, minus, and minus, minus. Which one is correct in this case? So I have to get it this one, minus 3 minus 8 minus 11, but I cannot write directly because of the leading coefficient. Now I can write it this part as the solution. So 6x square. Now this one I can write it as minus 3x minus 8x. Is it the same thing? Just in place of minus 11, just I split it. So what happened here? This is a common factor 3x. So it is 2x is a common. The remaining term has a minus 1. Here minus 4 is common, 2x minus 1. Now I will take this part as a common factor, 2x minus 1. The remaining part is 3x minus 4. So this is a final answer. So here the difference is the leading coefficient. Due to the leading coefficient, we will do it this part. Let us go with another example in the similar method of problems. So when I multiply these two, what happened here? Minus 42. So what are the multipliers here? You will have 1 into 42, then 2 into 21, 3 into how much? 3 into 14 times. Is it right? 3 into 14. And 4 not possible. 5 not possible. 6 into 7 times. So whenever you will have these two minus, we will have what? Large number minus. Large number will be minus. So for this type of problem, I need 11, minus 11. Therefore, this is a correct factor. But we cannot write it directly. Why? The reason is the leading coefficient. So I rewrite this term 2x square and then the minus 11 as 3x plus 3x minus 14x, and then the remaining you have minus 21. And similarly, this is we call it as grouping. We have taken the x is a common factor. You will get 2x plus 3, and here the common factor is minus 7. When I take minus 7, you will get 2x plus 3. And one more thing you can just remember, always in the grouping you will get a same term. Whatever be the terms you will have, you will get a same term. If it is getting the same term, you are going in the correct way. So it is 2x plus 3, and here the remaining is x minus 7. That's it. So this is a factoring trinomial. So we will have a 4 cases with the leading coefficient 1, and here the leading coefficient is not 1. So therefore we will have a grouping technique. And the next theorem, it is asking about the factorization theorem. So is the factorization theorem means, what the factorization theorem says? If b square minus 4ac equal perfect square, then it is factorable. It is factorable over integer. If it is not, it is not factorable. That's it. So this is the factorization theorem. If b square minus 4ac not equal to the perfect square, not factorable over integer. Over integer. Let us go with this one here. So first, what do you mean by perfect square? Perfect square. This is a perfect square number. We will get it here as 1. 1 square, which is 1. 2 square, 4. 3 square, 9. 4 square, it is 16. So these are the numbers, is called it as a perfect square number. Let us solve the first problem here. So a, here a, this is a, this is b, this is c. So I got it the values. So b square minus 4ac. So I just substitute. B is what? 8 minus 4 times of a is 4 minus 7. So therefore the value will be 8 minus of minus plus, it is 16 into 7. So 16 into 7. So therefore you will get it here 240, then here 11. So it is not a perfect square. Is it right? So 120 is not a perfect square number. Now let us go to the next one. So I say here it's not perfect square. So I write it the conclusion, not factorable over integer. Why? Because it is not a perfect square, not a perfect square. Now let us go with another problem. Here you have, so there is a b. So b square minus 4ac, same rule. So this is a and this is a b is minus 5 and c is minus 4. So b square minus 4ac equals, so it is 5 minus 5 whole square minus 4 into 6 into minus 4. So it is 25 minus half minus plus 16 into 6. So which is equal 96 and which is equal 121, which is a perfect square. That is equal 11 square. Therefore, so it is factorable over integer. It is factorable over integer. So this is the factorization theorem. If it is not perfect square, we say it is not factorable. If it is a perfect square, it is factorable over integer. Now the next one, the last topic of this video, which is special factoring. So before going to the special factoring, we have to know some of the formulas here. We have to know the special formulas. So what are the formulas we are using in this special factoring? The first one, as we studied in the before topic, these three topics, that is a plus b whole square. What is the rule? A square plus 2ab plus b square. And here a minus b whole square, which is the only change in minus. And the next one, it is a square minus b square. So you will have 1 plus 1 minus. And similarly, the new results here, we are going to use this part. A cube plus b cube. So what is the rule? So it is a plus b, then a square minus opposite sign. So here it will be a same sign, and here it is opposite sign. AB minus AB plus b square. So this is the formula. Similarly, for minus, a cube minus b cube, the rule is a minus b, a square minus ab plus b square. So here the same story we will repeating. So therefore this is the same sign. Here you will have opposite sign. And one more thing, it is only 2ab, not 2ab. Many students will write it here, it is 2ab. So it is only ab, not 2ab. So this is the formula we are going to use in the special factoring. Now the first one, it is of the format, it is a square minus b square. It is of this format, clear? So I can write it this one 7x whole square and this is 12 whole square. So I can easily use this rule. I can easily use this rule. So what is this rule here? So we have 1 plus 1 minus. So I write it here 7x plus 12 and 7x minus 12. That's it. This is a factor. So if you remember the formula, it will be very easy. So now here x power a power 4. We don't have the formula for a power 4. We have the formula for a power 2, a power 3. So I converted this one as a square whole square minus this is what 9 square. Now I can apply the a square minus b square rule where a is equal this one, b equal this one. So what happened here? A square minus 9, a square plus 9. So is the factorization is completed here? No, because we have the formula for the minus as well. So it is again, this one is again factorized by a minus 3 and a plus 3. And by the way, the plus, we don't have the formula for a square plus b square. That's why I keep it as it is this part. We have the only the formula for a square minus b square. That's why it is factorized further. Now the next one here we will have, this is the whole thing is my a, and this is, I can write it as 3 square. This can be written as 3 square. The b is 3. The b is 3 here. So I can rewrite this one more step. So I can write it x minus 2 whole square minus 3 square. It's the same rule, 1 plus 1 minus, where this is my a and this is my b. So I can write it this part as x minus 2 plus 3, x minus 2 minus 3. So this is the rule. Now simplify this part, you will get x plus 1, x minus 5. That's it. So this is the factoring. Now the last problem here, we are using power 3. So you have a power 3, easily you can identify a cube plus b cube, you have to use the rule. So I will use this part here, a cube minus b cube. What happened here? A cube, that is 2a whole cube plus 4b whole cube. If you apply the cube inside, you will get 8a cube. Here 64b cube. Now this is my a, this is b. This is a and this is b. So I write it the rule first. Therefore, a cube plus b cube is given by a plus b, then a square minus ab plus b square. So as per this rule, I just substitute the rule here. So you will get 2a plus 4b. This is done. This part is over. Now, the next one, a square, it is 4a square minus multiply a and b. So you will have what? 2a into 4b. The last part is 4b square, which is 16b square. Now the next step, I will simplify. I want to simplify this one. So here you will get 4a square minus 8ab plus 16b square. That's it. And here I will use the different one, which is, I can use the minus, so that it will be a different problem. Yeah. Now I will use the same rule. So it is power 3. So how will you write this one? It is 3x power 3 minus 5y power 3. So as per this one, I can go with this rule. This is a and this is b. So what is the rule here? A cube minus b cube. So a minus b, because starting will be the same sign, minus. The next will be opposite sign, a square plus ab plus b square. Now just substitute the values here, a and b. So you will get the first part 3x minus 5y. This part is over. Now the next one, 3a square. This is 9x square plus 3x into 5y plus 5y square. What is that one? It is 25y square. And the final answer will be 3x minus 5y. And here 9x square plus 15xy plus 25y square. That's it. Good. So with this topic is completed. Thank you.